Okay, so thank you everyone for being here. Welcome to NYU. Welcome to Hack3D 2022 fall. Today we will be going over the presentations for the finals that everyone has done yesterday. So by now all of you should know Hack3D is our biannual global cybersecurity competition as part of CSAW'. The challenges are focused on...
It's a semi-annual.
We've been holding it twice a year.
It's a semi-annual.
Okay, it's a semi-annual global cybersecurity competition where the challenges are focused on cybersecurity, digital manufacturing, reverse engineering, sabotage, counterfeit protection, and IP theft. Usually when we hold these competitions, we take a stance of red team versus blue team, where the red team is the giver of the challenge and the blue team has to solve it, taken from the standpoint of a hacker and someone that has been hacked. Today, our organizers are the esteemed Professor Nikhil Gupta, Hammond Pearce, researcher and postdoc here, Gary Mag, and myself, Caleb. Our finalists today, we had 6 teams from a wide range of universities and backgrounds, ranging from right here in New York, all the way to UT Austin, Clemson University in South Carolina, to IIT Bombay, Purdue University, and Vellore, just to name a few. Our judges today are, you're gonna have to help me again, George Curaco, the COO and co-founder of Bot Factory, where they make 3D printed circuit boards. Professor Ghaffar Galani, professor at CUNY New York City College of Technology, and the founder of the Center for Medical Devices and Additive Manufacturing, where they strongly foster undergraduate students to pursue research in additive manufacturing and how it can help the field of medicine. And last but certainly not least, we have Jian Yu, Dr. Jian Yu, from the Convergent Manufacturing Team at DevCom Army Research Laboratory, where they are doing a lot of research on how multi-material processes and multi-process additive manufacturing can impact Army uses. So this year's challenge, we had a lot of fun making it. It tested your guys' skills in model editing, image processing, decrypting and decoding, as well as evaluating G-code. Just to name a few of the things that you guys had to do, you also had to figure out how QR codes work, which was fun. So the puzzles were these 5, where you had to go through the step file and recognize where I hid everything. The Braille decoding, which was just a little section. Hopefully you guys all found it. The font and cipher decoding, where I gave you guys a weird font, and then I hid a secret message in there. Then you had to recognize that the G-code had stuff hidden both inside the text and inside the physical model, as well as finding an image and using some sort of color correction in order to find the hidden dimensions inside of the image. So now just to move on, today our presentation order will be Team Tesseract, Neo, Ankita and Leon, Missilepav, Roar, and finally Virtuosos. So as you're able to, Team Tesseract, one of your representatives, please come up. And I will have you begin presenting. I think it was this one. Yep.
Let's get started. Hi everyone, we are Team Tesseract.
I am Harak Pukan from SIM University, India. I'm Si Yuchun from UT Austin.
I'm Sinali. I'm also from UT Austin.
Two of the judges are online, so you might want to speak closer to the.
Okay, sure. Yeah. Okay.
So this is the first clue which we found. So when we saw the model in exploded view,
If you take a minute to just introduce yourself in terms of your backgrounds, are you a
Yeah.
PhD student or master's, and
Sure,
what field
sure.
are you? So that will help in
Okay.
gauging your skill level.
Yeah, sure.
So I'm Bhairav Phukan. I am a bachelor student in engineering, computer science engineering in SIM University in India, and I have also a specialization in software engineering as well. And
Yeah, my name is Sinali. I'm a fourth year PhD student, and my research is focused on using deep learning to do generative design technology. Yeah.
My name is Si Yuchun, and I'm new PhD student from UT Austin. And my research is the multi-agent reinforcement learning.
So moving on to the presentation. So like this is the first clue which we found, and when we took the model and we saw it in exploded view, and when we found a QR code inside the screen of the gaming console, and when we saw the console like QR code, we saw that it was not scannable, and because of the quality and the color which we had. So what we did was we saw that there was some inverted colors there and the QR code was inverted. So what we did was we studied how QR codes are made and the intricacies of QR codes, how so we did some research on that and how QR codes are generated basically. So and then we took a basic scan of the QR code with leaving out all the colors, and then we used something a basic tool as MS Paint. So what I did was I colored the boxes which were there using the fill option, and after that we found that the QR code got scanned easily, and then it took us to hint 3, which was a Google Drive PDF file. And there we found then there was an ancient text which we had to decode, and the first line said decipher the font, and the second line said decode the cipher. So we used this image and we put it on Google. We saw that it was like some form of ancient text. It's also called Pokemon alphabet, if you see, because the gaming console name was Hackmon. And after that, if you see the first line, it says decipher the font, and the second one says decode the cipher. Okay, and so like what we did was we decoded the ancient text, and we found that it looked like kind of like a Caesar cipher. And what we did was we decrypted Caesar cipher, and we saw that it said the crest on the legendary's head is 288 degrees plus 0. So this is the dimension, and we thought this is the dimension and the tolerance which of the Nintendo after NYU Switch. And this was the hint 3 which we saw, and after that CU will explain you the step file, like where the link was there.
Yeah. Then we went to the step file, and there we found a G-code file from the link shown as below. Then we went to the G-code file. We opened the G-code file in Notepad++. At the very beginning part of the G-code, there is a sentence shown in the very beginning of the part, and it shows that the dimension you seek reaches from peak to peak. And we think the from peak to peak is really important information here, and the minimum is 0, but the same maximum is buried in the lowest portion of the test. So we also think, then we think the tolerance of the minimum of the tolerance should be 0, but the tolerance of the maximum of the tolerance is buried in the test. And we went to the end of the G code. Then we found the dimension should be equal to Z max is equal to 75.5, and the tolerance should be buried inside of the model. And then we went to the model of the G code file. Then we found there is a number shown on the model. It is 0.02. So we think that the dimension should be the 75.5, and the tolerance should be the 0 to the plus 0.02. And from the information from peak to peak, we think it should belong to the number 1. And then we went to the step file. There is an element shown here, and there is an information shown that the dimension should be equal to 61.23, and the tolerance is from minus 0.23 to plus 0.01. And we are thinking about that because the dimension of the number 1 is equal to 75.5, and the scale of the number 2 should be smaller than number 1. So we think about that. So the dimension of the number 2 should be the 71. Yeah, this number. So according to the scale.
Yeah, so those are all the results that we found. We, unfortunately, we couldn't find all the clues, but still, we think we found other clues, but we didn't know how to interpret them. For example, in the G-code file, the physical model, we can see there is a sentence called methodology of link, the motion hat. We think it should be the top of this G-code model, but we tried to find some clues over there, but we couldn't find any. And also there is a sentence called like the power you seek is mirror tip-to-tip ancient Cartesian script. We were thinking this Cartesian script could be the sign underneath the in the bottom part of this base, but still we didn't get any luck there. And for this one, for example, this one you use your wisdom to open the Asian text. I think this should correspond to the Pokemon Go text. So basically, after to this point, we were thinking that for each side of the base of the model should lead us, should also explain us how to crack those information that the clues that we obtain. But maybe this is the one that we use, but for others we didn't quite use them. So this one we tried different angles and we try to read, try to tilt and try to rotate, but finally we still didn't get the whole sentence. I marked the question there. For example, we can read some words like the carrot or find the minimal dimension, maybe a hidden within the sword. So we checked the sword of this model, but we still didn't find any evidence there. And another one is this point matrix, and we tried different methods like binary coding, treating the black dots as 1 and the white dots as 0. So we try to decode those binary codes, but we didn't get information. We also tried like pseudocode and pseudoc. We try to interpret different numbers and try to see whether we can find some information. And also we also try to connect different points to form different alphabets or numbers, but we still couldn't find any. Yeah. So this is our final result, and we only, as I mentioned, we only got 3 results, and I think that even though we didn't get all the results out, I think we really enjoyed this game. This is a very great game, and we really enjoyed it, and I think we had a great teamwork, and that. Bahira, he flies from India to the US, so that was good. That was one thing. Then we got a reunion. That's very good. And yeah, we really want like more time to to get more down on this design problems. Even after the design challenge, we spend some time to crack the different, for example, after the submission, we thought this should be, just as mentioned, this should be some text and designed for like blind people. They can tag them to get the information as like braille text. So yeah, after submission, we couldn't do anything. Yeah, that's it. Yeah, thank you so much. Yeah.
So now we will be taking questions from our judges. Let's start with George here.
Everything was nicely done. Good work, by the way. Just a question. When you did the outline in the QR code, you showed that you took all the lines of all the shapes. How did you do this? So you didn't simply invert the colors here, exactly, the left one.
Yeah, so what we did was we removed this was the original QR code, right? The red thing, and I think Xinjiang took there's options where you can remove the color. We just took a picture of the thing, and we tried to remove all the colors, and we just took the outline of the QR code.
Okay.
Yeah, and after that, we saw that after that, what we did was we took this the plain QR code and the red one, and we compared the two. If we also there were some QR codes on NYU Tangent, like we also studied those. We took pictures and studied and compared how QR codes work, like how the URL is inside the QR code. And then what I did was I colored each one of the boxes with paint.
Okay, so you went manually.
Yeah.
Okay.
So so it took around 1 hour to fill it manually, and after that, when I scanned it, directly took us to the link.
Okay, thank you.
Now, if Professor Galani has any questions.
Well, actually, I was interested in knowing more about how they dealt with the QR code. So the question was released already.
Yeah, we tried different methods, and finally we think maybe we should go for the manual, and it worked. Yeah.
And if Dr. Jiang has any questions he would like to ask.
Sure. Yes. Now we have a very diverse team here. How do you feel your team dynamic works in solving this puzzle? Do you talk about do you enjoy it, or you have a leadership in the team, or how you delegate each task? Thank you.
Yeah, sure. Actually, me and Xinjiang has participated earlier in ASME competitions, and in the Hack3D competition we took CU, and I think we have a really good dynamic as to teamwork. And when we were in India, when we were solving the qualifying challenge, so we had a very long time difference. So Xinjiang was working in at night, and I was working in the morning, or sometimes I was working at night, he's working in the morning. So I think we know our strengths, where we so I can do the coding and the manual things, and Xinjiang can do the research part, and CU can use the tools of the G code. So we have what we do is we add our strengths, and we try to find out what we can in the problem. So when we start with the problem, we first analyze the problem and we make a list. And what we do is we assign each one of the according to the strengths, we assign each problem. So yesterday after supposing Yang is very good in documentation, so we were very close to the submission line, and Gang was doing the documentation, and me and Siu were still finding the code, and we were doing the last bit, and after the submission we got to know, we found that it was real, but it was too late by then.
Thank you. I'm glad you guys kind of enjoy working on this puzzle.
Yeah, thank you so much.
Thank you.
All right. Okay. Let's have one more round of applause for Team Petra. You guys did fantastic. Now let's, I will stop sharing my screen. If a representative from Team Neo would share their screen.
How much time does each team have?
Each team has roughly 15 minutes, including questions from the judges. I haven't heard from Team yet, so We don't have any, are any of them from,
I don't have any samples.
are any of them in the meeting?
No response.
All right. All right. Well, moving on then. I believe next would be Ankita and Leon. So moving right along. Sorry. Let me just try to hide this. I don't know how to make it go away. I'm sorry.
You put that in presentation mode.
Oh, right.
Hi, good morning everyone. I'm Ankita from.
Louder.
Okay.
Yeah.
Okay. Good morning everyone. I'm Ankita Shinde. I'm a PhD NYU student from mechanical engineering. We have the team like Ankita and this is Leon.
Oh, my name is Leon Lloyd. I'm a mechanical engineer graduate student, and we're here to present our 3D hackathon solutions. Here are the contents we'll be going over.
We first found the solution is that we were given the file or in the step file. We had the option of going into two things. The one was the Fusion 3 and 380, and the another was we directly opened it into the AutoCAD file. AutoCAD file gave us into the whole image into the wireframe. As it gave us image into the wireframe, we could actually find out there was a circle in which the dimension was written, from which we actually got the dimension like okay it would be 61.23 and the tolerance was exactly written there. As you can see, it's plus 0.07 to that minus 0.23 tolerance. That was what we could actually get from this image. And in this process actually initially we you can say when we opened it into the fusion file, it was like the closed solid thing, so we couldn't figure out anything. So we tried to open it into the another file, that is the AutoCAD, and this is the result what we got. The next solution is the QR code. Actually, when we saw the we then again opened when we saw it in the wireframe itself, the wireframe view that is in the AutoCAD, we saw there was the QR code like this given, but it didn't had the it didn't had filled all the dots. So what we did is we actually did manually filled all the dots. We actually saw how the QR codes are made and how exactly are they to be done, and by that we actually manually filled these things. After scanning it through through one of my phone, after scanning it, we got one more clue. In that clue there was this sheet where it was written it was an unknown Pokemon character. After googling it what unknown alphabets are, we could find that there is a decoding of it. So after decoding this, we could find this was the you can say the decoding, out of which we got the solution as the crest on the legend head is 288 plus 0. That was one of our dimension. That was the dimension which was of the rectangular you can say shape which we saw in the hackathon. And yeah, okay. Leon will continue from here.
And for solution 3 in the AutoCAD file, we also have a link, a 10-year link, which opens a drive, and in the drive you get a G-code. First, we opened the G-code file in Notepad++, and at the very beginning of the file, you can see they give us a hint. The dimension you seek is from peak to peak. Minimum is 0, but Z maximum is buried in the lowest portion of the text. And so then we just scroll to the very bottom of the G code, and somewhere at the bottom you get this hint. Gives you the dimension directly, and it tells you that the tolerance is inside the model. So then we open the model inside Ultimate Picura, and you get this sword. And we did notice the text at the bottom portion, but we didn't think much of it. We couldn't interpret it, but we did see that on the blade there was. We don't have. We forgot to put a picture, but on the blade there is a number which we interpreted as 0.02, and on the other side it was a 7, or we thought it was a 7. So we decided the tolerance would be plus 0.02 and minus 7. For solution 4, with the dots on the grid, we initially thought back to the preliminary solution where they had the letters corresponding to the black dots, but that didn't give us anything. And then we tried to think about the other puzzle from the preliminary, which had the numbers corresponding to the digital clock, but that didn't give us a solution either. And somewhere along the way, I noticed that the dots were raised from the platform, so I thought it would be Braille alphabet, which we just looked up a translation for, and it gives us the hint down here. And after we got that hint, we did not know where to proceed, so we don't have a tolerance or dimension from this hint. And for the fifth, last hint, we didn't see anywhere, and we couldn't, so we don't have any idea of where to go to find the fifth hint. And so for our which dimension correlates to which part on the Pokemon card tree, the solution we found with our solution 2 corresponds to dimension 3 since it's the only one with an angle in it, and we just decided for the other solutions we found it can't be 4 because it's too small, and so we decided just 1 and 5. And these are all the solutions that we were able to find.
So now once again, let's take some questions from our judges, starting with George.
So I'm going through everything you guys did. So when you find the braille, I mean, it's very impressive. You were within striking distance in that braille. I'm eager to understand, when you saw down there, what did you try?
Okay, we tried encoding it into like 2012 1010.
No, forget that. You found that it decodes to down there.
Yes,
Because
yes,
you were
yes,
so
yes.
close. That's why I'm
Yeah.
so interested. So after you saw the down there,
Yeah,
what did you guys do?
We just
went
it was like the
looking down.
yeah, the preliminary round. We just tried turning pieces
Yeah.
or hiding pieces and looking like
Yeah.
inside the circles. Because in the preliminary round there was one of the puzzles where a number was inside a peg, and so we looked around and we didn't really see anything.
Okay, so you actually took the individual part
Yes.
that had the braille. Okay. Okay. Cool. Thank you.
I'm sure we probably missed something like right there.
Yeah. And I have one more question that has to do a little bit with a blade. You said that your conclusion was 0.02 and 7.
7. I mean, we just flipped the blade,
I understand.
and then it just looked like 7 to us.
So 7 is a big dimension.
But we just
Okay.
thought it's like 75.7 is the, you can say, the largest dimension which we found on the tip. So we thought that might be exist.
Got it. So your final submission was for the tolerance was plus 0.02 and minus 7.
Yeah.
Okay. Thank you.
Now, if Professor Galani has any questions.
Oh, sorry, I muted myself at some time. Yeah, it was a good presentation. I'm just trying to figure out what you are trying to say in the last slide of the conclusion. and how many solutions we can understand now you were able to conclude. I think
We
the
should.
previous one. So we're saying solution 2. I just got lost. I'm trying to remember which one was solution 2.
Oh, yeah, we
That's
should have
all.
included a table, but solution 2 was the cipher, which gave us the angle, and that's solution 3 because it's the only one on the cartridge that has an angle as a dimension. And solution 1, and the other two solutions we found were the 75.5 and 67, and we just decided 1.5 because 75 was the longer side and 67 was the shorter side.
As it's a rectangle.
All right. If Professor Galani has no more questions, we can move on to Dr. Yu.
Yep. Very good teams. Doing your solving the puzzle, when do you feel like, okay, all right, we did the best we can, and kind of say, okay, this is done for the night? Do you the frustration, how do you cope with it?
We were actually very, I mean, it was really tiring. At one point, we were like, we are done now. But, we just kept looking at it. And after looking at it, and we were thinking at the back of the mind, the process actually went on. But at one point, it was like, okay, let's see that there might be something, And it just came up accordingly. But at the end, it was like sick, like we had our deadline and we felt like, I don't know, I think we did what we did. So that was the point where we could conclude.
Yeah, thank you, team. Well done.
All right. Let's have one more round of applause for.
I think pretty close to the brain. Yeah, so close.
All righty.
Now moving right along, I believe next is Team Missile Pav.
So if one of your representatives is able to share their screen.
Hello, I'll be sharing my screen.
Can we begin?
Yes, whenever you're ready.
All right. A very good morning, everybody. This is Diksha Sharma from Symbiosis, India, and we're Team Missile Power. You're here to present our findings on the challenge Hack3D. This is our team. We have Akash Jain from Purdue University, Vishnu from BITS, Sumiran from VIT, and I'm from Symbiosis. Let's look at the flow of the presentation. We have our problem introduction, then the findings, the final outcome, and lastly, the conclusion of the presentation. So to introduce you to the challenge that we were given, we had an engineering drawing of a gaming console, which had missing dimensions and tolerances, and a step file containing the NYU Nintendo gaming console, which was held with the clues, and we were supposed to find the dimensions in total. So to start up with the findings, I'll hand it over to Vishnu. So over to you, Vishnu.
So the first solution that we found was in the step file. This was actually a small gear that we found, and on it basically written was dimension 61.23 and tolerance plus 0.07 minus 0.23. This is what we wrote down. Next, we found a QR code under the screen of the console. In Fusion itself, we changed the color from red to white and from white to black. And then we were able to scan the QR code, which led us to a URL, which then led us to the PDF file, which had stylized letters of the alphabet. We solved this using the Caesar cipher, and this told us that the angle, the dimension number 3, was 288 degrees and the corresponding tolerance was 0. I next call upon Sumiran to Akar to explain the Braille.
Hi. So we immediately saw that there was a Braille clue in the place of where the speaker is on the Game Boy console. Like we could recognize it because of like the 2x3 patterns, you know, that was formed by the demarcations. And so the message like initially translated to down here. So what we did with that, this took us a while to figure out, but we isolated the body which contained like the protrusions, and on the rear side we noticed that there was like there were several dots, and they were of like differing heights. So some were flat, most were at a certain height, and then there were some that were slightly taller. So if you can see the image on the right, we sort of color coded it just to make it clear. So the ones that are red are flat, and the ones that are like the tallest protrusions were blue. And after spending some time trying to like decode this, you know, initially we thought it might be binary, but we realized this is another Braille message. So if we kind of like start at the top left and like imagine again 2x3 rectangles, this also gives a Braille message. The ones which are red give DIM 55.5, and the blue ones give TOL plus minus 0.02. So then we concluded that one of the dimensions must be 55.5 and with a tolerance of plus minus 0.02. I'll hand it to Sumiran now to explain our next and final finding.
The fourth one. We found a URL on one of the panels that was part of the console step file, and it led us to a G-code file, a drive link of a G-code file titled Zelda Master Sword. So we ended up looking into that file, and we found one clue, which was dimension is equal to 75.5, which isn't part of your standard, you know, CNC or G-code kind of nomenclature. So we thought that was a definite clue. And the other one that we found was tall equals inside the model. So we figured that we need the model for this particular G-code file. So we opened up Ultimaker Cura as shown in the screenshots over here. And we ended up simulating the 3D printing process itself. And we found these two clues, 0.02, which was actually inverted on one of the sides of the sword, and a plus or minus sign on the other side. And there was also some other text which we found. So this made it quite clear that one of the clues, this particular one, was 75.5 plus or minus 0.02. So that was a final clue that we were able to find. For the final outcome, I'd like to hand it over to Akar.
Yeah. So these are the 4 dimensions / tolerances that we found, and in the previous slides we explained our thought process behind each of them. In terms of deciding which dimension was which, so 288 degrees must have been dimension 3 since it's the only angle, and we measured the sizes of the dimensions, like, you know, relative to each other from the engineering drawing. So Vishnu, could you move to the next slide? So yeah, so this is our final template. So from this engineering drawing, we can see that dimension 5 is the longest. So we reason that 75.5 and plus minus 0.02 is probably dimension 5. Next would be dimension 1 is 61.23 since it's like the second longest. And finally, dimension 2 is 55.5. And as a side note, we did find the 5th dimension after the challenge time had ended, but we're not considering that. All right, that is the end of our presentation.
Thank you. All right, you guys did a fantastic job. Now, if we would like to have questions from judges, George, if you would.
Yeah, tell me a little bit more about the sword challenge. You said that you found the tolerance to be plus minus 0.02. Can you describe a little bit in more detail? How did you define this?
Right. So after loading it into Cura, we actually started to look a bit more into what we saw that the surface of the kind of mantle or pedestal that the sword was attached to, it had some text. So we noticed that right away. So we tried to find some ways to make that text more clear. And essentially by varying the amounts of layers that are printed over here, we were able to see the different stages of the model itself and the way in which the surface varied. So we figured out the 4 sides of the text that was actually included in our report, but it's not over here. But yeah, we found the 4 sides of the text on the base of the sword. And as we were printing up, we saw these 2 red, irregularities along the width of the sword, the 0.02, and actually the plus minus is in there, but it's really difficult to see on the presentation. So I'm sorry for that. But yeah, so we didn't really figure out the plus minus at first. I was just staring at this 0.02 for a while, and I kind of thought that's the only thing it could mean. And I discussed it with my teammates, and Akar was looking at it too, and he agreed. So that's kind of how we went about finding the dimension. And plus minus, I mean, Akar suggested that the other side looks like plus minus, which when I looked at it, I saw that as well, but I didn't see it initially. So it was kind of, yeah, just us working together to get into the details of that.
Yeah, as we rotated the part around in Cura, one side we saw a 0.02, and then on the other side, the kind of red marking that we saw, it resembled a plus minus. So we went with that.
Okay, so it's from purely observing the part from the outside and kind of, guesstimate, correct?
Yeah, that's fair to say.
Okay, thank you.
All right, now if Professor Galani has any questions.
Yes, I like this presentation. It's very detailed and rich with contents.
Thank you, Professor.
And I see the challenge. I don't know how you guys work it out. Like everybody, it seems like from different institution. And I see number 4. What is the reason that you're unable to do anything about it, or it was
yeah,
difficult, or time issues?
So we had participated in the summer challenge as well, and interestingly, the same thing that happened there happened to us again. So the clue that we weren't able to find in the summer challenge was like a really tiny URL, and the same thing happened here. So after the challenge deadline was over, we found like a URL hidden in the step file, and it was pretty short, so we didn't see it initially. And when we opened it, it took us to an image. And yeah, as we kept working, we realized that the dimensions and tolerances were like hidden inside the image. And also the value of that dimension is smaller than each of the ones that we did find. I think, okay, I'm not going to share the value. No, that would be unfair. But it was smaller than all of these. So, and from the drawing, it can be seen that 4 is the smallest. So we reason that that must have been dimension 4 as well.
So the same group, you guys as a group participated in the same parts of the group?
Could you repeat that?
You said you did this in the summer, so it was the same group?
It was the same group, yes.
And how do you work from different?
How do we work on this? We
Yeah.
kind of just, tackled clues individually since we're all working remotely.
Thank you very much.
All right. If Dr. Jiang has any questions, or Dr. Yu has any questions?
Here's a comment. Well done, team. What do you think the outcome would change if you have a chance to meet in person rather than work remotely?
It is possible that the outcome would change because I did notice that sometimes we would kind of work on the same thing at the same time. So maybe we weren't using the time as efficiently as we could. But at the same time, it's also hard because, like, say for the Braille, for instance, that took us a very long time to figure out. We didn't get it until like within the last hour of the challenge because it was not an obvious clue at all. So it is hard. Like, yes, if we were in person, we could probably like work more efficiently as a team, but the difficulty of the challenge itself means that like maybe that effect wouldn't show and we'd still be scrambling to finish it.
Oh, thank you for answering. Go on, team.
Just
Yes,
to
Suren,
add,
Vishnu, do
I
you have any
think
thoughts on that? Yeah.
I think just to add to his point, meeting in person and working on it in person would have definitely helped us work faster and more efficiently. But I think we would have influenced each other's ideas a lot more. So we might not have found the Braille code because that like we got it in the last half hour, like Akar said. So maybe if all of our ideas would have rubbed off on each other, then the different spark, we could not have found that.
Could go either way.
Alrighty, let's have one more round of applause for Municipal. They have joined? Okay. Fantastic. So let's move back on to the team that was missing. If someone from Team Neo would like to share their screen.
Yep. Hello everyone. Apologies for the delay. So I hope the screen is visible.
Yep. Oh well, cut off.
Okay. I just shared the PPT, so yeah.
Yep.
It's visible. Cool. So we'll be beginning. Okay. Hello everyone. This is Team Neo, and this is our submission for Hack3D final challenge. We are Sneha, Prabhat, and Sirish. I and Sirish are from IIT Tirupati, and Prabhat is from IIT Bombay. Sirish was not able to join us for this PPT, so it will be just me and Prabhat presenting our solutions today. So the entire challenge was to find the dimensions, lengths of the various dimensions of a cartridge box used in this Nintendo controller. So our entire approach was looking into the step file in various modes, changing transparency, hiding the bodies, different solid bodies, and figuring out what it could be. So these were what we could find. These were our findings: 75.5 plus or minus 0.02, 61.23 plus or minus 0.01, minus 0.23, 288 degrees plus 0 minus 3. So our entire based on this and the solution template, again, based on relative dimensioning, we are like the 288 degrees correspond to the third clue, of course. 75.5 and 61.23, it's just a guess, since we weren't able to find the other two dimensions, that it could be dimension 5 and dimension 1, which are the largest and the second largest dimensions out there. So Prabhat will take over.
So yes, hello. So the first clue was this obtained from this QR code that we found in the step file. First, when we found it, we didn't know, we weren't sure if it was a QR code. So we just processed it using an image processing software, and then we used Google Lens to open it, and it was a QR code. And that led us to a file, a Google Drive link, in which we found the image on the right. So we didn't know what this was at first sight, but then later on we had the idea that this could be a Pokemon reference, because there was a Pokemon reference in the step file itself. So we found a Pokeball at one place, and so that we thought that might have led to this text. So we found that this was an unknown Pokemon script, and that once we understood that that was the font used, we found out on the left is what we is the same written in a different font. So it says decipher the font, decode the cipher, and we after looking at the cipher here, we thought it was a Caesar cipher, and it turns out it was Caesar cipher with shift 3. And that read the crest on the legendary set is 288 degrees plus 0. So here we thought the tolerance here is -3, and that was because the Caesar cipher shift is -3. So we believed that could have been the negative part of the tolerance, since the positive part wasn't mentioned. So our answer here is 288 plus 0 minus 3. Yeah, and that is the first clue. And the second clue is we relate to the second clue from this URL that we found in the step file. So this URL led us to a G code file. So that which contained this Zelda master sword file. It contained a sword, and it contained the G code file had. Upon opening it using Cura, we found a lot of text on all of these, all of the sites. And we also opened the G code file using a text editor, in which on the top, it read the dimension you seek reaches from peak to peak, and the minimum is 0, but Z maximum is buried in the lowest portion of the text. So upon reading this, we searched at the bottom of the file, and we found that the dimension is indeed 75.5, and the tolerance is inside the model. So once we found the tolerance is inside the model, so we knew that this inscriptions on the sword meant something. So first we thought it could have been a reference to the Zelda, Legend of Zelda, and we upon some web searching, we found out there is some language in Zelda itself. So it could have been a reference to that, is what we thought initially, but then we found no relation between that and this, so we had to give up on that idea. Later we did think like it could have been plus or minus, and this looked like 0.02 in an inverted fashion. So we ended up concluding that this indeed is the answer, plus and minus 0.02. So yes, that is how we obtained clue number 2.
So coming to clue number 3, the step file itself, this was one of this behavior it is, and this is one answer we are completely sure of. So this was visible clearly as one of the solid bodies in the entire step file. So which had dimension and tolerance engraved on opposite sides of this gear-like disk. So the answer here is 71.23 plus 0.01 and minus 0.23. So, and then coming to the fourth clue, it was Braille. So here is, so this was one thing which we were not sure how to go about. We had to go through different layers and look into the bodies separately, individually, layer 1, layer 2, like different solid bodies. Initially, we thought, it could be binary. And then later we realized there are extrusions and intrusions in the surface. And the funny part was some CAD softwares, some of the holes looked colored. In some CAD softwares, it did not. So then that is when we realized, let's look at the number of pegs here. And there was a hashtag here, which initially made us believe it could be something related to Sudoku too, but that did not make sense because there were not symmetric 3x3 squares everywhere. So finally, the only conclusion was Braille, since it was like 2x3 everywhere. So based on that and comparing the Braille alphabet, we found the text down here. We were not able to figure out what to do from beyond here. We went and searched the entire model up and down. And yeah, that was one dead end for us. The next clue was finding a URL in the rectangular section which housed the QR code. And going through this URL, we went through this drive folder, which gave us the poster of the upcoming Super Mario Bros. Movie. So the thing here also, we went through EAXIF data. We searched for if there is any steganographic data hidden in this poster, but we were unable to find anything. The only thing we were able to find here was that while going through the EXIF and the steganography decoder, that some modification was done to the image using a photo editor. So based on that, And one more thing is we tried comparing this image with the original poster, movie poster. And one major difference we found was here it is NYU Tendo plus contrast, but in the initial original poster, it is Nintendo plus illumination. So we thought we'll try changing the contrast and illumination of the poster and see if anything pops out. So, and when we did that, the text itself, NYU Tendo plus contrast, popped out when we made the contrast low, since it is an externally added feature. The other thing we found in the image was there's in this left barrel here, in the left corner of the image, bottom corner, there's a number 8 and there's a plus in the signboard here. That's all we were able to find. We were not able to go beyond this. So this is our solution for the final challenge. Thank you.
Alrighty, now let's have some questions from our judges. George, if you'd like.
Yeah, the last one is what interests me the most at this point with the image. So you say that you changed the contrast, and how did you change the contrast?
We used a photo editing software, some online tools as well as offline ones. And when we changed the contrast, whatever additionally added text, it got highlighted. So
Okay,
the
not
more
in the image that you're showing, right?
Yep.
This is the unedited image, correct?
This is the edited image. This is the original image which was given to us with added data, and we were not able to completely decode what's hidden. Only we were able to partially decode it. We got an 8 here and we got a plus here. Yeah.
Okay. Okay. Did you try multiple tools for the contrast or just one?
Sorry, could you please repeat the question?
Did you try multiple tools? You said you used an online editing photo tool.
Since we are working virtually, some of us used online tools, some of us used the tools we have on our desktop. But yeah, the stark differences we could observe was these. Yes.
Okay. Okay. Thank you. Very, very good job. You guys actually touched on all the challenges. You had bumps here and there, but you managed to at least identify all the challenges.
Thank you.
Alrighty. So now, if Professor Galani would like to ask questions.
Yeah, I like this presentation too. Very detailed. And for the first time, I see a group was looking at the Super Mario, which is very interesting. So I understand that you guys did 3 out of 5, right? So
yes, sir.
Yeah. So what was the challenge that you were unable to do all 5 of them? Is it a matter of time, or just you were unable to figure out the next step?
It was both time and one more factor which kind of stumped us during this challenge was that all of us were involved with something else. Our tests and exams are going on. So we had to divert our attention to both of these. So timing as well as time, both were the issues for the attending the problem.
I would like to add to that. Actually, the last time we've also participated in the summer challenge, and that time it was a 24-hour competition. So we didn't really have this time issue, but this time around we had to spend time during the night. So maybe that might have impacted our, I don't know, coordination and thinking a little bit.
Do you think if you get more time, you would be able to figure out the remaining?
Yes, maybe so.
Alrighty. Now, if Dr. Yu has any questions.
Yeah. Well done, team. I mean, I think you guys went the furthest so far. In retrospect, what could you have done better in terms of teamwork, let's say, to make it accomplish more of the puzzle?
Well, one thing is we could have every time we actually have a discussion, we sit down and we open a Google Meet link and we just sit down and all of us try to solve the problem at the same time. That's generally how we coordinate. But we also, there's also an individual aspect to it in that we just talk to each other while we're coordinating, but we don't actually use the screen share feature or something like that. We don't look at, we don't solve on one problem together, but we could have tried that also. We could have tried focusing on one particular problem, all of us trying to focus on one particular problem. That might have helped us figure solutions out for questions in lesser time than what we would have taken. So that's one way.
Yep, thank you, team. Well done.
All right, let's have one more round of applause. Great work, everyone. So now is our last in-person team before the last remote team. So if the representatives from team Roar would like to come up. Alrighty, you guys can take it away.
Okay. Hello, everyone. I'm Shaman. I'm a part of Team Roar, and I'm doing my master's in automotive engineering, and my focus is on lean and smart manufacturing. I'm here with my team.
So my name is Ethan Westcoat. I'm a PhD student in mechanical engineering. My focus is on condition-based monitoring for manufacturing equipment.
And then I'm Flanagan Walder, also a PhD student, but in automotive engineering, looking at human interactions with technology in automotive assembly.
Okay, coming back to our presentation. So we'll be covering all these contents throughout the presentation. And coming to our introduction and problem statement, we were given a step file of NYU Tendos, and also we were supposed to find the dimensions and the tolerance for each as shown in this figure for the Nintendo cartridge. And so this is our final solution, which will be touching upon on like our each finding for each dimensions and the tolerance. And we try to match the dimensions based on like the 61.23 for our width and the length as 75 based on the length or the size. And
yeah, so getting right into it, we'll just sort of go in order as we numbered them, given the solution template. So dimension 1 was more or less was given to us, just manipulation of the step file, hiding different components, inspecting everything independently. Came across this style, printed around one side, tolerance around the other side, dimension. So that one. Dimension 2 was a bit.
Sorry.
Oh no, sorry. Dimension 2 is a bit more involved. Of course, that's the Braille riddle that everyone seemed to struggle with. So nice to hear it wasn't just us, but we noticed the tic-tac-toe pattern pretty quickly, and given a similar pattern in the initial challenge, or for the preliminary challenge for the fall at least, I don't know what the summer looked like. But we had 3x3 grids in a similar tic-tac-toe pattern with letters represented by some marked positions in those grids. So this time around, we struggled a bit more. I don't know who wound up figuring out it was Braille, but once we got to that point, we quickly find that it said down here. And after a little more fumbling around, managed to flip it over, noted the pegs on the back side of the part, different heights, and by sorting by those heights, I identified 2 sets of letters in Braille, numbers, 2 messages in Braille, one with the dimension 5.5, and another with the tolerance, which I can put on the slide, but we had it in our solution. And then dimension 3 goes back to the QR code. We found that rather quickly, again, through direct manipulation of the step file, hiding components, trying to look at everything from all the angles we could. So you remove the screen off the NYU Tendo device. You see this right below it. And truthfully, I can't speak to how we actually got it to scan. That was Ethan's department. I think he's just playing with recoloring it directly in SolidWorks. I was using Fusion 360, so I was having some trouble. But we got to the Pokemon unknown alphabet. I'll note that that is the correct spelling of unknown for Pokemon, according to Google. But came to the same message. decipher the font, decode the cipher, followed by the cipher. And none of us have a background in cryptography, again, automotive and mechanical engineering. So I just Googled cipher solver, and I think the website I used actually treated it as a substitution cipher, which I think sort of works the same way. But the reason I say that is because you can see we manually changed it. Initially said the crest on the legendary set is 288 degrees plus 0 because there's no letter V used. So we caught on to that, at least despite our lack of experience in that domain, corrected it to 0, and that gave us dimension 3.
Yeah, for dimension 4, we did the file manipulation again, and we realized that there was a URL. There were 2 URL codes, and so for this one, when we opened up the URL code in a file explorer, we got the image that you see over to the right, and so the provided clue that we interpreted from that was that we needed to change the contrast of the image itself, and so we messed around a lot with the brightness and clarity of the image to eventually decipher what we thought were the dimensions and tolerances, and so you can kind of make it out very faintly for the dimension right there. It's 10.02, and then it's a little bit more clear for the same filtering and contrast, but you can see the tolerance there as 0.4 and negative 0.005. So, yeah. And then so for dimension 5, that other URL code opened up the G code itself, and so for this we found the hint in the header, and so initially we thought that the max Z 75.5 was what it was, but then scrolling all the way to the bottom, as was mentioned in the clue with the 0 plus peak to peak, we found the dim equals Z max equals 75.5, which was the same, and also realized that the tolerance is equal to inside the model was the other part of that clue. So what we initially did is we looked through the sort again, looking at layer by layer. We realized there was some writing, so we removed the helper and the toolpath of the actual G code in Cura. We thought it looked like a 7, gonna be honest. So that's why we came out with the tolerance as being 0.07 and didn't really know what to think about the other side of the sword. But yeah, that's what we did. So conclusions, we believe we found all the dimensions and tolerances. What we thought as our keys to success was the independent work distribution. We kind of all began by going off in our own directions. But then as we were finding things, we had that multi-level verification of being able to come back and like verify each other's answers. Again, the file manipulation skills was something that was a very key aspect of it. I mean, we're all versed in Cura, SolidWorks, Fusion 360. And then active communication and dynamically resharing tasks. As we were getting frustrated with stuff, like we would move to other things and then come back to it later once we had a clear head, or so to speak. And so some of the lessons that we learned was we learned more about the G-code manipulation, additional aspects about Cura that we didn't know about beforehand, and then, of course, the being able to hide messages and images as well, image steganography. So some of the broader impacts. So as I said, I'm condition-based monitoring for manufacturing equipment, and so I don't really know all that much about cybersecurity beforehand, but it has me now thinking a little bit more about how this can affect my work, especially when we look at false data. So in one case, I'm worried about catching early failures, but if somebody were to hide a late failure in that early failure data, it might cause me to either miss a maintenance task for my work in particular.
Yep, and then for my work, I mentioned working with humans. Of course, in any case where you're collecting human data, mine is particularly on sort of mental states, cognitive workloads. Data privacy is critical. You go to, I know in the EU especially, again, just drawing from my background in automotive, just implementing vision systems in factories is massively difficult given the privacy rights that people have. And of course, you want reliable feedback. Automotive workers are pretty clever about doing things to do less work, stopping the line, breaking machines on the extreme end. But you want to make sure the data that you're getting is true, is reflective of the conditions you're looking to monitor.
And so, yeah.
Thank you.
Switching to
Clemson.
Clemson.
Everyone.
All of us.
Okay.
Sorry. Yeah.
Awesome. So now let's have some questions from our judges. As usual, George, you want to go first?
fantastic job, guys. I mean, you touched on all the challenges and you found the results from all the challenges. Especially impressive that as you mentioned, you had to decipher. Of course, the easiest type of deciphering. However, if you've never taken any security class, then it's I cannot imagine how it looks. And of course, you utilized everything that was there to find a solution. For me, although I do not consider by any stretch this challenge to be the toughest, for you, I think it was the most impressive because with no background there, you came through a very good job throughout the challenge.
All right. Now, Professor Galani has any questions? Professor Galani,
Yes,
if you
yes,
yeah,
sorry. Yeah, it's a great presentation. And I like the fact that you mentioned you are introduced to cybersecurity, though, and you are working on manufacturing also. So now the knowledge you gained from here, how do you think from this project, this knowledge can be implemented in manufacturing and production since you are already in that field?
So for my work in particular, really just making sure the data is of the highest quality is one aspect of it, and that if somebody were to make an attack against my model or my algorithms, how do I verify that that's true data that I'm getting versus faulty data is one thing that I'm looking at. So how do I encrypt the way that I'm receiving data and possibly decrypting it too?
Yeah, and then for my side, on the human side, again, it really just comes down to the security of the data, making sure that it gets shared where it's allowed to and nowhere else. And I guess these challenges in particular don't have the most direct application of the type of data I'm collecting, but the broader context of just looking at the different data types, looking at novel manipulations and how not only you're able to hide data, but how people are able to manipulate your data in potentially unforeseen ways has really been my biggest takeaway from this challenge.
Good stuff. And if Dr. Yu has any questions?
Yeah, just a general question about the teamwork. In hindsight, let's say you will manage to get all the clues and all the answers. How do you kind of work together in terms of team and assignments, and were you guys very happy after you found all 5?
Yes, we were really happy, and I think it has to do with the coordination among the team members. And if we are we couldn't find any solutions or we don't have any leads, then we would assign the same task to some other teammate, and then we take up the next task and try to optimize the work distribution. And yeah.
Yeah, I'll say the form of our collaboration in this case was somewhat different. The first challenge, we were all taking our classes, doing our normal daily work. Hammond and Ethan were in Greenville, South Carolina at the CUI car campus, the automotive engineering campus. I had class down in Clemson. So it's sort of a piecewise, sort of hybrid, asynchronous mode of work. Being able to all, even if we hadn't all been sitting together, to be able to dedicate a block of time and all work at the same thing all at the same time, collaboratively, in a more direct collaborative sense, I guess I should say. Big impact. That's fine.
Yeah. Thank you, team.
Thank you.
All right, excellent. Now we have one last presentation tonight, or this morning. I guess it's night for some people. We have Team Virtuosos. So you guys can now present your screen.
Okay. Hello everyone, I'm Pratiksha Davade, along with Gladson Thomas from Team Users. I'm from Maharashtra Institute of Technology, Aurangabad, Maharashtra, from India. So let's move towards presentation. So the problem statement. Nintendo is releasing gaming console, and we found the design of cartridge, but all the dimensions and tolerance we are missing. So we got an early prototype of some consoles, and which had all the dimensions and tolerance hidden in it. We were hello, am I audible?
Yeah, you're audible.
Okay,
Yeah,
okay,
sorry,
okay.
I muted us on our end, so you guys can keep going.
Okay, okay. In that we had all the measurements and the tolerances hidden in that console file, and then we were tasked to extract all the dimensions and the tolerances from it. So move towards clues. We got a clue on the side of the gaming console. There is a volume wheel, and upon that inspections, we found some text on it. It directly these dimensions and tolerances. Like the dimension is 61.23, and tolerance is plus 0.07 and minus 0.023. So next clue. Uh, Also, we also saw the small text hidden near to the bottom of the screen, and following that link, we got a drive link, and also in that which had the poster for the Super Mario Bros. Movie, and we compared that poster with the original poster, and apart from that, the obvious changes like only in theater, etc. One change we felt significant to us, and the text on the top of the poster, which read Nintendo plus contrast. Then we felt like that answer would have something to do with the contrast of the image, and then we played with the contrast a little bit, and we found that the this text on it, and that like a dimension and tolerance. Then we got answer like a dimension as a 10.02, and the tolerance as a plus 0.4, and minus 0.005. Then over to you, Gladson.
Okay. Am I audible clearly? Hello?
Yeah, whatever.
Okay. So after opening up that model in CAD assistant software, we saw this figure inside the screen, and these three blocks made us realize that it was a QR code of these three corner blocks. And fortunately we saw this figure when we were watching it through wireframe mode. So we took screenshot of it, and we inverted the colors, and we put that in Photopea, an online Photoshop alternative. So since it was of outlines, we fill the colors. First we inverted them, then we fill black colors in all these blocks, so that it could be scanned by mobile. So we took our mobile and scanned it, and we found this URL.
and after following the URL, we found this PDF in a Google Drive link, which was from that URL, and we again scan this through Google Lens, and after scanning, we found out that it was actually font known as script known as unknown alphabet, which was from Pokemon, and each of the symbols represented an English character. So we wrote all that down. And we found this text from that, decipher the font and decode the cipher, and then this was some text, and while looking at the text we understood that it was a Caesar cipher, and fun fact, it was from the last year's qualification challenge of the Hack3D. We learned about the Caesar cipher, so this time we were able to use that. We understood that it was Caesar cipher, and then we tried different keys here, and using -3 keys we were reversing back, and we used -3. Then we could unlock this text, the crest of the legendary head, and we understood that it was the answer, where it read 288. So we used that as a dimension, and +0 we understood that it was a tolerance. Okay, so for this one we saw another link in the battery cover, and we used that link. It was also a shortened link, and it also led to a Google Drive, and we found a G code there. We downloaded that, and we opened that in VS Code, and first we saw this comment here, and also we knew that in the lowest portion of the text the answer would be there. So we scrolled down, and we found this Z75.5. So it was separated a bit, so we knew that it could be the answer, and it also had the Z in it. So with reference to the first one, we figured that this could be the answer. And also there was this one, tolerance is equal to inside the model. So we knew that the tolerance would be inside the model, but unfortunately we were not able to figure that out. We saw something on the sword, but we could not able to figure that out. So after getting all the calculations, we wrote all that down, and so this was a mistake. We found that after submitting, so this was not real. Okay, so after having all the dimensions and tolerances, we saw the figure, the figure which was given to us, and arranged that according to the sizes, and we arranged all these dimensions. So this is our final answer. Okay, so any questions? We are open to questions now.
Oh, do that one more time. I was muted. They couldn't hear it yet.
Did this team participate in summer or no? This is the first time.
I don't remember looking at that. Okay. All right. So now our judges can ask questions. So starting with George.
Okay, good job, guys. One quick question. You mentioned that you compared the poster with the original poster. Can you elaborate a little bit on how you did the comparison?
Yeah, we checked both the posters, and we thought that if there was something different in the original and this one, so that could be the answer. But we could not find any such differences. The only difference which was significant was that contrast instead of illumination. So we played with the contrast, and that's how we could get the answer.
So the comparison that you're mentioning with the original is simply by observing through naked eye, correct?
Yeah.
Okay. Thank you.
All right. If Professor Galani has any questions.
Thank you very much. The great presentation, very detailed. So what was the most challenging one among the four that you have figured out? And what did you learn from it?
Yeah, there was much to learn, and the hardest one of the unsolved was that the speaker grid one. We knew that it could be a clue, but we could not figure out that it was a braille. And from that four, which we found out, the hardest one was that a sword, that Zelda sword thing. We could not figure that one out too. We just found that the dimension.
What did you learn from the whole process?
If you'd be able to repeat that, I don't know if we heard you quite clearly.
I said, what did you learn from the whole process?
We learned about mainly about the teamwork. Actually, we had planned about doing that together. As the previous time it was a 24-hour format, so we planned accordingly. In our time zone, it would be the 12 o'clock in the night. It would be actually 9:30 in the morning. So we could, so we planned that we would do together for the starting for the day, and after 5 o'clock or something, then we would do separately. So we could have the both aspects, like doing together, then we could collaborate to do, and then after separating, then we could individually figure that out, so it could confirm each other's proofs. So we hope that, but according to the time zones, it was actually from 8:30 to 3 a.m. of the night. So that was.
And if Dr. Yu has any questions?
Yeah, very good effort, team. Since you have a team of 2 people, do you feel that you are kind of overwhelmed and underhanded? Would an extra teammate help?
Yeah, definitely. That could have helped, we guess.
We consider, like, let's say you want to do another competition like this again, will you kind of invite maybe a 3rd or 4th team member?
Yeah, we would definitely like to add more team members, but actually we would like to also have team members who would participate actively. So that's why we were holding on only 2 right now. So that everyone who participates would do it with the whole heart. So that's why we kept it at 2.
Yeah, well, it's very good of you too. I mean, you can what you have done, with 2 people, actually pretty hard for you guys. I know. but yeah, thank you. Yeah, well done.
Thank you.
All right, thank you so much. Let's have one more round of applause. If you wouldn't mind, okay. All right. So that sort of brings us to a close. We have had all of the teams present now. You guys all did really fantastic. I think I spent too much time designing this thing, so I'm really happy that you guys were able to find everything that you did, especially in the ways that you did. You guys came up with some really creative stuff. So let's have one more round of applause for everyone that's here and online.
A round of applause for Caleb. I mean, this puzzle is an amazing puzzle. Thank you for setting this up.
Thank you.
Are you going to show the solution now?
Should I share the solution?
No, they are done with their presentation.
Okay. Okay, not that one. Here, hold on, let me stop sharing my screen for the people here while I find where I shoved my solution document. Because I don't have it downloaded. Because I'm a great at planning.
Yeah, actually, I found out one error in the solution sheet. It's the 0.4, not 0.04.
The winners will be announced tomorrow. Okay. After the judges have had time to deliberate.
Yeah, all the competitions are.
Okay. So I'm sharing once again.
Yeah, let's give time to judges afterwards. So that's what we do.
Yep. So just very carefully, I do appreciate the guys from Clemson touching on everything that I said, or everything that they said at the end there. I was following an attack vector while producing this challenge, so it's very helpful that you guys picked up on that. Just scrolling down, these were the correct dimensions from everything, and just this is what the judges are going to be following for their deliberations. Obviously, we have the gear, we have the Braille puzzle, we have the QR code with the hidden text. The whole time while looking at this, I was making a reference to this Pokemon game in particular, because that's what I had on my desk next to me. Going through again, yes, in the tiniest portion I could figure out how to. I hid this link, just as I wanted this one to be the hardest puzzle. So I did hide the dimensions in these two areas, and the intention was for you to figure out some way to adjust the brightness and the contrast, mostly the contrast because the varying shades, in order to make the colors come out. Scrolling down further, you have the other link, which brings you to the sword. So each one of the sides that you guys looked at, two of the sides were just directing you to open the file in some kind of text editor. The last side was directing you to look at what was hidden here on the model. And then the fourth side was just me having fun, making a reference to Legend of Zelda Minish Cap.
Okay. That's highly misleading.
You're welcome.
It's a good security. Yeah.
So,
Hey,
yes.
hey, Caleb.
Can I?
Sorry, Caleb. I saw that one of the contrast solution, the tolerance would be 0.4, I think, not 0.04. See the picture? It should be 0.4, right? 0.4.
Yeah, 0.4. That would be me writing it down, forgetting how decimal points work.
Okay, there you go.
Alrighty. So, yep, there we go. That's the solution. I'm glad that I got the chance to torture everyone.
Can I say that I appreciate the reference to the Triforces with power, courage, and wisdom? That was really neat.
Yeah, that's. I think it was Ocarina that had the pedestal, and so I was trying to make fun of that one. And my least favorite Zelda game. All right. So now that you guys have all seen the solution, our in-person guests, you guys can leave while the judges are deliberating. And I'm pretty sure Gary is going to kick everyone that isn't a judge off of this call.
Okay, thank you, everybody.
All right. Thank you so much all for coming.